For this example, let's look at integrating the rational function 9x squared plus 16x plus 45 divided by x plus 4 times x squared plus 9. So what we notice here in our rational function is that the degree of the denominator is larger than the degree of the numerator, and the denominator consists of a linear factor, x plus 4, and a quadratic factor, x squared plus 9, which is irreducible. So that means that this can be decomposed as a constant over the linear factor and a linear term, let's say bx plus c, over the irreducible quadratic factor. Now if we put these two terms over a common denominator, which will be x plus 4 times x squared plus 9, the numerator will be a times x squared plus 9 plus the bx plus c times x plus 4. And now we have two expressions with the same numerator. Two expressions with the same denominator, so the numerators have to be equal. So that means then that 9x squared plus 16x plus 45 equals a times x squared plus 9 plus bx plus c times x plus 4. And now the job is to find a, b, and c. So first, let's choose x equal to -4, because that will knock out b and c on the right-hand side of the equation. So if x is -4, then on the left we have 9 times 16 plus 16 times -4 plus 45, and then on the right-hand side we'll have 25 times a. Now if we solve this, we get that a equals 5. Now to find c, b, let's look at the coefficients of x squared on the left-hand side of the equation and on the right-hand side of the equation. So what we have is the coefficient of x squared on the left-hand side of the equation is 9, and that has to equal the coefficient of x squared on the right-hand side of the equation. On the right-hand side of the equation, the coefficient of x squared comes here, and it also comes from the b here if we were to multiply this out. So what we have then is that 9 has to equal a plus b. Since we know that a equals 5, this means then that b equals 4. So now we found both a and b, and all we have to do is find c. To find c, let's equate the constants on both sides of the equation. So on the left-hand side, the constant is 45. And on the right-hand side, the constant will be coming from the 9a here and the 4c here. And now, since we know the value of a is 5, we have 45 equals 9 times 5 plus 4 times c, which means that c equals 0. So now let's put these constants back into the decomposed rational function so that we're ready to integrate. So then the integral becomes the integral of a over x plus 4 plus bx plus c, so 4x plus 0, over x squared plus 9. Now this right here will be a natural log, and to do this integral right here, we're going to do a little u substitution off to the side. So let's let u equal x squared plus 9. Then du is going to equal 2x dx. So that means that the integral of 4x over x squared plus 9 dx is equal to the integral of, well, I put u here for x squared plus 9. I have this 4 here, and then what's remaining is x dx. X dx is just 1/2 du. So this becomes the same as integrating, if we clean it up a little bit, 2 times the integral of 1 over u du, which is 2 times the natural log of the absolute value of u plus constant of integration. And doing a back substitution, we let u equal x squared plus 9, which means we can drop those absolute values, since x squared plus 9 will always be positive, and this will be that part of the integral. So now let's go back and put this result in here and solve the other part of the problem, and we have that this integral is 5 times the natural log of the absolute value of x plus 4 plus 2 times the natural log of x squared plus 9 plus a constant of integration.